Welcome to another Bosch Rexroth training video. Today we'll be covering suction cups, or suction pads as they are also known. This video is intended for internal use only. Distribution of the video outside the Bosch Rexroth SA group of companies is not permitted, and failure to adhere thereto will result in disciplinary action. Vacuum suction cups. What is a suction cup? A suction cup is also known as a sucker, or a device or object that makes use of negative air pressure to adhere to a surface of a product. Suction cups, or pads as they are also known, are the link between the workpiece and the handling system. These suction cups come in various shapes and sizes depending on the different objects to be lifted. Suction cup design. Suction cups have two parts. Part 1, connection nipple. This is the connection from the vacuum source to the actual suction pad. These come in various sizes and are also in the option of male or female thread to suit the different size suction cups. These connection nipples will differ from suction cup to suction cup, so this means you will not be able to use the same item for all sizes. Part 2 is the suction pad. This is the connection from the nipple to the workpiece itself. These suction pads can be replaced after their service life has been succeeded. These come in a wide variety of different materials depending on the application. They consist of a sealing lip, sealing flange, and internal structure with the aids of effectiveness of the suction cups. Functional principle. Internal volume. The internal volume is the internal capacity of a suction cup that has to be evacuated and therefore influences the time for evacuation. Stroke of the sealing lip. The stroke of the sealing lip describes the way the suction cup retreats after it was charged with vacuum. It has a direct influence on the relative movement of the sealing lip. Minimum curve radius of the workpiece. The minimum curve radius is the smallest radius of workpiece that can still be securely gripped by the suction cup. Suction cup stroke. This is the lifting effect which occurs during evacuation of the suction cup, especially on bellow suction cups, which equals max contraction of the suction cup. Suction cups, how do they work? A suction pad does not attach itself to a surface of a workpiece. Instead, the ambient air pressure, or atmospheric pressure, presses the suction pad against the workpiece as soon as the ambient pressure is greater than the pressure between the suction pad and workpiece. The pressure difference is achieved by connecting the suction pad to a vacuum generator, which evacuates the air from the space between the pad and the workpiece. If the suction pad is in contact with the surface of the workpiece, no air can enter it from the sides, and a vacuum is generated. Suction cup holding force. The holding force of a suction cup increases proportionally with the difference between the ambient pressure and the pressure inside the cup. The holding force of a suction cup is calculated with the formula. Holding force equals delta P, or pressure difference between ambient pressure and the pressure in the vacuum system, times the area for the suction cup. This answer will be given as a unit newtons. It can be converted to kilos by simply dividing by 10. Therefore, if you require a greater holding force for a particular workpiece, you will need to increase the pressure difference or use a suction cap with a larger area or diameter. Here you will see the dimensional differences between the PFYN 150 and PFYN 200 suction cups from Schmaltz. You can see clearly that the holding forces between the two differ. The 150 mm cup gives a holding force of 842 newtons versus 1498 newtons from the 200 mm suction cup. So if converting this to kilograms, you have 84 kilos from the 150 and 149.8 from the 200 mm. It is important to note that these specs are measured at a vacuum level of minus 0.6 bar on a smooth surface. Should the surface be rough or porous, there is a chance that the vacuum level will be less, causing the suction cup holding force to decrease. Suction cup shapes. Flat suction cups. Flat suction cups are particularly suited for handling workpieces that are flat or slightly curved surfaces. Flat suction pads can be evacuated quickly due to their flat shape and low inner volume. Therefore, they can grip the workpiece in very short times and can withstand the forces which result from fast movement of the objects during the handling process. Advantages of flat suction cups: large variety of different suction pad materials, example silicone, natural rubber, PVC, to name a few. Variety of different shapes, so round, oval, steep or flat leveling sealing lips. Flat shapes and low inner volume result in minimum evacuation time. Good stability of the suction pad allows for higher shear forces and positioning accuracy while workpieces are picked up. Flat suction cups continued. Handling of smooth or lightly rough workpieces, such as sheet metal plates, glass plates, wooden boards, and even corrugated sheets. In automated processes with short cycling times. As you can see in here, there are a few examples of the flat suction cups picking up various materials. SPK suction plate. Round suction plates for handling of objects with very rough or structured surface, such as ornamental glass, checkered plate, broken natural stone, etc. Flexible sealing ring can easily be replaced separately when worn. The SPC series suction cup comes with a separation function. This is used when lifting porous wood materials such as MDF and hardboard. The problem experienced with suction cups is that once the suction commences, this will often pick up the first layer and the second layer due to the porous properties of the product. The solution is SPC suction plate from Schmaltz. This cup has a separation function built in, which prevents the self-adhesing during the unstacking of the sheets. This is how it works. The cup functions as a normal cup. When vacuum is applied at the connection B, this will allow the suction cup to grip the workpiece. However, in porous materials such as MDF, this will also cause a stuck-through effect, which in turn will cause the sticking effect of the board below. By injecting a pulse of compressed air into the center of the suction cup, this will allow the flow through the top workpiece to the one underneath. The compressed air will cancel out the vacuum pressure, thus forcing the bottom boards to be released. This is now possible to pick up only the top layer. Bellows suction cups. Bellows suction pads have the following characteristics and advantages: good adaptation to uneven surfaces, compensation of differences in height, fragile workpieces are picked up gently. Disadvantages: lower holding force when compared to the same diameter in the flat suction cups. This is mainly due to the internal diameter differences between the two types. The bellows suction cup almost always has a smaller internal diameter due to their design. Number of folds. When it comes to bellows cups, there are a few different types. Here you will see the FSGA 1.5 fold cup versus the FSG 2.5 cup. These are called folds, as they are also known as bellows. Typical areas of application: handling of curved or uneven workpieces such as body materials and cardboard, handling of fragile workpieces such as electronic components, injection molded plastic parts, handling of non-rigid or flexible workpieces such as packaged or shrink wrap products. Chemical resistance. Applications in ambient conditions are important for the selection of right suction pads and appropriate materials. Abrasion resistance, oil resistance, and food safety are often required for a suction pad. These requirements can be met by selecting the appropriate materials. Here you'll see a table with the types of materials or chemical designations for each of the optionals available. Also, you will see the chemical resistance for each of these materials. From these specifications, you will choose the best suited type of material to use depending on the chemical resistance needed. Color coding of suction cups can assist in the identification of the different materials. However, this can differ from supplier to supplier. Schmaltz used the different colors to identify the industry rather than the material of the suction cup. Example, silicon can be clear, white, green, or light blue, depending on the packaging industry. However, the anti-static SI cup used in the electronic industry will be black with a white dot. Mechanical characteristics. Wear resistance. If a suction pad is chosen that has a low wear resistance, will generally be a softer material, which will lead to a good sealing contact on the product. However, the downside to this will be that suction cup will wear out a lot faster. So you will need to choose the cup with the best sealing properties, but also with the highest wear resistance possible. Temperature resistance. This is a very important factor when it comes to suction pad materials. It is vital to know the short-term temperatures and the long-term temperatures of the product to be lifted or gripped, as it will lead to premature wear or failure of the suction pad should it not be spec'd correctly. Additional characteristics. Food grade. These are materials suited to be used whenever a suction pad is making direct contact with a food product. The materials generally used in these applications is silicon. Leaving few marks. When a suction pad has made contact with a product, it can leave a mark where the contact was made. So in some applications, for example, solar, glass, or some instances, the plastic industries will require a pad with a material that will leave less marks on the end product. Absence of paint wetting, impairment substances. In the automotive industry, it is important to use a suction pad with absence of PWIS, as this will lead to poor quality of the painted product after it has been gripped with a suction pad. Suction cups, important types. Vacuum suction cups for different industries. Here are some of the specific cups for the different industries, namely metal, packaging, wood, glass, plastics, and composites. We trust you enjoyed this training. For any further information regarding this training presentation, please contact the Bosch Rexroth SA Training Department. Thank you.